Hello, smart people. Hope you'll be fine. So this is our fifth lecture on tensors. So in previous topic, we have discussed about how to calculate that dot and cross product of vectors using some kind of a mathematical symbol like Lewis Strauss symbol. And with the help of that symbol, so we are able to calculate the cross product and calculate the different components if you take the cross product between the two vectors, right? Now, today's lecture is about the vector transformation. So if we do that vector transformation from from one frame, from some unprimed frame to primed frame, right? So let us talk about now if we have so that means if we consider that if our this vector lies in an xy plane, right, and it makes some angle alpha with this, and we rotate this with respect to this. And this angle will be some theta. So that means we're considering that or this vector is in xy plane, so our vector is some r, right? So we're rotating it with respect to along this z-axis, right? And if you write now, so how you can write this transformation, this x prime. So how you can relate this x prime when you move this vector from some unprimed frame from some xy plane to x prime y prime plane, right? So we can write now, so we can get this relation that x prime will be equal to that x cos theta. Okay. So that means well, so in xy this in xy plane, so we can write that our x will be so x will be equal to so that will be equal to r cos alpha and y will be equal to r sin. Okay, because it makes some angle alpha with this x-axis, right? Then you can write that r will be x will be equal to that r cos alpha and that y will be equal to r sin alpha, right? Now if you write now, because I'm moving this some vector r from this xy to x prime y prime plane. Okay, so that means our x prime will be equal to. So we can write that our x prime will be equal to. Because this is that alpha plus theta. Okay, because I'm moving it from this xy plane to x prime y prime plane, right? Now our vector, so we need to write now x prime in terms of that x, right? In order to get these relations, how these vectors transform when you move from some xy to x prime y prime. Right? If you move some vector, so we can rewrite. So this is simply that cos of a plus b. So this is equal to. So this is simply that sin of a plus b sin a cos a plus cos a sin b, right? And similarly, that cos of a plus b equal to this, right? Now you use this because I can relate that x is equal to that is some r cos alpha and y equal to r sin alpha. So if I use here, so that means instead of that x, I can use that this one. So instead of x, instead of that r cos alpha, I can write that x, and instead of that r sin alpha, I will use y in both of these equations, right? So if I rewrite this equation, so x prime will be equal to, so that will be equal to x cos theta minus y sin theta, right? because this r cos alpha equal to that is x, so this is x cos theta, and now r cos this and this r sin alpha, so r sin alpha equal to y, so this will be minus y sin theta, so that is this term minus y sin theta. And similarly, let's have a look on the y component, so y prime, so y prime will be equal to, so instead of this r cos r sin alpha, so you use that x, so this will be equal to x cos theta plus, and instead of this r cos alpha you will use y, so that is y. Okay, so we have these relations now. That's x prime is x cos theta minus y sin theta, and y prime will be equal to x cos theta plus y sin theta. So why I'm doing this, I need to write, so how this vector transforms if you go from some unprimed frame to primed frame, right? So from xy to x prime y prime. So how you can relate this how this vector transform, so going from one frame to another frame, or how these are related to each other, you can say that. So this is what I wrote here, x prime, you are writing in terms of that xy. So that means this is basically that this primed frame, right? Or you can say that rotating frame, some new frame. And similarly, y prime is our new frame. This is related to the older frame with our that matrices, that's in terms of sines and cosines, right? So let us rewrite this term. Now if you change now the angle, if you change now theta to minus theta, right? So if you write now, if theta goes to minus theta, right? So what will happen to these equations? So let us go back. Let me rewrite these equations. So that is x cos theta minus y sin theta. And okay. So if I change now, so if I write now, so this is equal to y prime equal to y cos theta plus x sin theta. That's correct. Okay. So that means if I change now theta to minus theta, so in that case, so this is a given function, so this will not change, but this will change because sines are not a function. So that means by changing theta to minus theta, so this will be equal to x cos theta plus y sin of theta, because this will be sine of minus theta, that's minus sine of theta, so this will be plus y sin theta, and this is minus. Okay, so that means I can write that x prime y prime, so this I can write as, so this is how you can relate these rotated with the unrotated frame of reference, right? With these matrix element, so that's in terms of that sines and cosine. So this about transformation, so what we do, so this is orthogonal transform, because these are at, so this transformation what we do here, so this transformation is orthogonal. So this transformation is, now if you write now, so let us calculate now. So we have this now, x prime is equal to x cos theta plus y sin theta. If you see the variation with respect to the space coordinate, so that means if I write now, so what's our dx prime from here? So if I differentiate this equation, so dx prime for this one equal to, And what about that transformation anxiety? We can say that and z dash equal to that. Because when moving it in a plane in an xy plane, right? I'm changing this vector r from xy to x prime y prime plane because it is invariant. So the motion is along with this. Motion is in xy plane, you can say. So that's why I can write here z dash equal to z, right? Now if you calculate now, so because you can say that the distance, this distance between any two points does not depend upon the choice of coordinates. So अगर for example मैं यहाँ पे if I have some frame, right, so if you want to calculate the distance between the two points, so you are calculating the length, the distance of that length element, right? You want to measure that length. So that length means invariant if you choose, if you move, if you go from one frame to another frame. तो अगर हम एक फ्रेम में जाएंगे और in some another frame, so this length remains invariant. So that means, or you can say that the distance between the two points, that it wholly depends on the choice of coordinates that I'm using. Coordinate matters. You can use any coordinate system. You can go from one frame to some other moving frame of reference also, right? And this distance it remains invariant. Okay. So let us calculate now. So we have calculated what is our dx prime, right? And dy prime will be equal to this, and so from here you can write that dz prime will be equal to dz. Now, so that means here I'm saying that the distance between the two points remains invariant. So that means the square of the length in between the two frames, in the primary frame, or you can talk about this. If you want to calculate now the distance here, if you want to calculate the distance between any two points in xy plane, in unprimary frame, so the square of that length should be equal to the distance between the two pointers in the primary frame of reference, right? So I can write them. So I can write them. So what is our delta x prime square? So delta x prime square, it should be equal to delta x. So what is delta x prime square? So that is dx prime square. So that should be equal to. So this is what indicates that square of the this length that remains invariant if you go from one frame to another frame, right? So let's calculate this because we have. So we know that. So from our previous this slide we have this dx prime equal to this one and dy prime equal to this one, right? So I can write them dx prime will be equal to dx cos theta. Okay, because we have this. So this is our left hand side. So because dx prime, so you just check that our dx prime equal to dx cos theta plus dy sin theta ka whole square, and similarly our dy prime is this one minus dx sin theta plus dy cos theta ka whole square, and these are prime equal to these are. So this is what I wrote here. So so that's equal to these are square. So this is our that left hand. So very left hand side here. So let us evaluate this. So this should be equal to that it should be equal to delta x square, right? So that means this length should remain anywhere, right? So let's do it. So let's calculate now. So what is this stuff? So this will be. So this is, if you combine these two equations, so this is dx cos square theta plus dy dx sin square theta. So you can take dx square out. So this will be simply that dx square. Then you combine this term and this term, because you take that dx square common, and this is sin square theta plus cos square theta. It should be equal to 1. And similarly, you can combine this term and this term. So again, you can take that dy square common from these two terms, and inside will be sin square theta plus cos square theta. So that's equal to 1. So we have then dy. And similarly, let's have look on this term. तो ये वाली जो term हमारी है, तो यहाँ पे it is twice dx dy sin theta cos theta. This is minus type. So this term will cancel with this one, right? And the left, the last term, that is dz. So that means we have calculated that delta x prime square should be equal to delta x. So that means the distance between any two points is the square of that length element. It remains invariant. So it hardly matters what type of coordinate system we are choosing. So it remains invariant, right? So let us uh, discuss now. So if we have, if we calculate now, so that means this finite length, so from point A to B. So this I can also calculate by integrating that path, right? So we can also calculate it by integrating that path. Like if we have this, so we can calculate that delta S prime will be equal to that A to B. So if you take this length element ds, right, and this will be equal to delta S. Okay. So this is how you can. Okay, let me write. So this should be here. So it should be prime. Okay. So this is the length element. You can also calculate it by integrating that equation from some limits A to B. You calculate that length, right? Now, so if you talk about this in Newtonian mechanics, so if you let's go back. In Newtonian mechanics, we are saying that the time interval, so time interval is an invariant quantity. So the time interval means the distance, the time between the two pointers from point A to point B. So that means that time interval remains invariant. So if we go in classical mechanics, right, or Newtonian mechanics, I can say. So it hardly matters. Suppose you want to measure the time interval in one frame of reference, and with the same watch, you are calculating that time interval in some new frame of reference. So it hardly matters, right? So we can say that in Newtonian mechanics, the time interval is an invariant quantity, right? So let us have some, if we अगर हमारे पास कोई equation होगी like some this Newton's second law F equal to ma. So let us see that we can also calculate it with the help of these transformation equations, right? So we can write here, if you rewrite those terms, so we have this, if you remember that from our original equation, that dx is equal to, that is dx cos theta plus dy sin of theta, and so it is not necessary. You can also take that, if you take variation, this transformation in horizontal plane. So that means then this x remains, then dx prime will be equal to dx, right? So because I am taking that motion in xy plane, or you are making your transformation in some xy plane, right? Provided that z is constant. Okay. And if you multiply it by 1 by t, so you need to multiply this term by 1 by dt. Okay. So, so that means we can rewrite this equation. So this will be dx prime upon dt prime. because I have to multiply this dt prime on the left hand side, because this is basically for this primary frame of reference. So that's why I multiply by 1 by dt prime. Here you have to multiply by 1 by. So that means on the right hand side you need to multiply by 1 by dt, and on the right hand side you need to multiply by 1 by dt. And on the left hand side you need to multiply by 1 by dt, right? Because that's in the primary frame, those coordinates, right? So you can write similarly for dz. So no need to write because our motion you are taking about, you are only talking about that xy plane, right? So that means this gives us. So if you derive this term, so this will be equal to vx prime. Okay. Right. So this is the velocity. So let us go back. So if you write now, so similarly, our vz prime will be equal to, or you can write that's equal to vz. Right? So that's very clear. Okay. Now what about these Newton's laws? So we have that F equal to ma. So that means let us again multiply this by 1 by dt prime. So I should get that x dash, right? So that means our vx prime equal to, that is vx. Okay. And if you multiply by again by dx prime, so this gives me, that is uh, ax dash will be equal to, that is ax cos of theta plus. Okay. So we can write now here. So this is clear. So from this, so this is the how we can, this velocity gets transformed from some unprimed to primed frame, or you from primed to unprimed frame, and similarly you can write for the acceleration. But remember one thing: if you talk about now, what about the components? This ax prime is not equal to x, right? And similarly, you can also write for this ay prime is not equal to, but az prime equal to az, right? Because our, so that coordinate remains invariant because our motion is in the xy plane, right? So these are not true in general. So that means I cannot write that our f x prime will be equal to f of x or fy prime. Right? So that means, okay, but I have the same relation in both the frames of reference. So that means I can have this f prime will be equal to ma prime, and f will be equal to m, right? So that means this is the Newton's law, the form of the equation in both the frames remain the same. So that means we should, this is valid in that private frame, and this is valid for unprivate frame. Or I can say that our f, so I can say that this fk equal to m, right? So this quantity remains invariant in both the frames, right? Now let us, because as I already told you, so they are the same relation in both the frames of reference. But I can say that fk is, so this is an invariant quantity, I can say, right? Now if you go back, so if I write now, what will be our, so from this equation, so from your previous equation, if I rewrite now, we have this x prime, we have this x prime equal to, uh, we have this x prime, okay, uh, we have this x prime equal to, that's x cos theta plus y sin theta, and similarly y prime will be equal to minus x sin theta plus y cos. Now, if you calculate from here, what is our, if you calculate what will be our partial x prime upon partial x, right? Or you can rewrite this as, okay, let me write one more setup. So let me write here. So our this dx prime, that is equal to, okay. So if I calculate now what is our partial x prime upon partial x, to take this differential partially with respect to x. So I can get here, because when you take its variation with respect to that partial x, so this term will be equal to 1. So we'll get here cos theta. And partial y prime by partial y. So that's equal to minus, so that's plus cos theta, sorry. Because you are taking partial y prime by partial y, so that is cos theta. And similarly, if you take that partial x prime upon partial y, that is sin theta, and partial y prime equal to minus sin. So let's have a look. So what I calculate here. So if I differentiate this partially with respect to x, so that's partial x prime by partial x, so we'll get only cos theta because you're differentiating it partially with respect to x. So this term will survive because we have that partial x by partial x, so that's 1. So this will be cos theta. And this is partial y by partial x, that's equal to 0 because you are differentiating partially with respect to x, right? And similarly, on second equation, you can write that partial y prime by, that is partial y prime by partial y, that's cos theta. So this term will survive because this is equal to 1. And similarly, if you take its variation with respect to x, so that's partial y prime by partial x. So that should be equal to minus sin theta because this is for partial dx, partial x by partial x, that's equal to 1. So we have these kinds of equations from these transformations when we make that, when we are calculating the differential element, right? Dx prime and dy prime. Okay, so let us, and similarly, I can write for, so what's our equation? So this equation, let us rewrite this equation. So ये equation क्या बन गई हमारी? So this equation becomes, so our x prime will be equal to, so this will be x. So instead of this cos theta, you write that partial x prime plus y, and sin theta, instead of sin theta, you write, okay, and you can write that, what's our y prime then? So that's equal to x, and this is minus sin theta. So minus sin theta is partial y prime by partial x. And then dy, so this is plus y, and then cos theta, and cos theta is equal to partial y prime by partial. Okay, now we have these equations. So let us generalize these equations, and we can also write for this and z prime equal to, so that's clear. So if you don't write, so because one is the transformation variation goes in xy plane, right? And this z prime equal to z. तो यहाँ पे मैंने क्या किया, I simply write that x prime equal to x cos theta. So this is x. तो cos theta के बदले मैंने लिखा partial x prime by partial x. So this is this term and plus y. Plus y. Now sin theta. Instead of sin theta, you write partial x prime by partial y. So this is the first this transformation equation. And second transformation equation will be that y prime will be equal to that is equal to x and minus sin theta. Now minus sin theta is partial y prime by partial x. So this first term. And the second term is that's plus y cos theta. So plus y and cos theta. Instead of cos theta, you write partial y prime by partial y. That's it. Now I have these two equations. So let us generalize these equations, because if you remember in one of this lecture when we discussed the maybe in first or second lecture on tensors, so I basically changed the notation. So in order to write something in some compact form, some equation in some compact form, right? So let us label that. Let us put that x1 equal to x. Okay. So I can rewrite this equation. So let us check this equation. So this x prime. So this equation instead of this equation. So this equation के बदले that x prime partial by partial x. So x prime equal to x partial x by partial x plus partial y by. So is it partial y by partial? Let's check. So x equal to x prime equal to x partial x prime by partial x prime by partial x and plus y partial x prime by partial y. So that is so here it is. So let me write here. Okay. So let us check if it is right. So okay. X partial x prime by partial x plus y partial, that's correct. Now is the equation के बाद because I am saying that I'm general I want to write it in some compact form, because I am writing it for some position vector. Similarly, I can write for if I have some vector A, some velocity or acceleration or something else. Right? So I can generalize it. I can rewrite this term for those quantities also, right? So instead of this equation, I can write that our x prime I will be equal to summation j xg. Okay, so let us check this. तो ये जो मैंने इक्वेशन लिखी है, तो let us check this. So j runs from 1 to 2 because we have this only x and y coordinate means so j can take value 1 or j can take value 2. So 1 corresponds to our x coordinate because x1 equal to x, x2 equal to y, and x3 equal to z, right? So let's try rewrite this term. So if I put now, so let us put here some. If you put here I equal to 1 in this equation, if you put I equal to 1, so that means I can write this equation x prime 1. So this equation because I equal to 1, so that's equal to, and j is running from 1 to 2, right? So we can write that this is from 1 to, can I write this term also. So this will be equal to x1 partial x prime 1 by. So just check if I'm right. So यहाँ पे I का because I takes values 1, so x prime 1, right, equal to x1 because first j will take one value, so x1 partial x prime 1 by partial x because initially first value taken by this j is 1, so this x1 and x prime will be 1, and now here it is again 1 because I is fixed, I is taking only I equal to 1 here, and now j will be here, it will be x2 and partial x2 because here it is j, here it is j. So that means we can write that partial x prime 1 is partial x. So that means, so x prime, you can write this is equal to, that's x because x1 equal to x, and that is partial x prime by partial x plus. So just check if I'm right. Because first is x1 equal to x. So this is partial x prime because x1 prime equal to x prime, right? Because x1 corresponds to x coordinate, first coordinate. So that's partial x prime by partial x plus, now x2 is equal to y. So following this notation, right? So x2 equal to y, partial x prime by partial y. So this is the same equation. What I get here, right? Now instead of that, if you write now, and similarly for y, if you put I equal to 2, so if you put I equal to 2, अगर मैं I2 यहाँ पे लूँगा, so that means I can write then x prime 2 will be equal to, okay. So this term is equal to, if you remember that, so this term will be equal to x partial y prime by partial x plus y partial y prime by partial y. So this is our second transformation equation. Just check it. So this is this equation. That means partial x prime by this y prime is equal to, or y prime is equal to, that is this x partial y prime by partial x plus y partial y prime by partial x. So this I can get from here because you can rewrite this term as, so this term will be equal to x partial y prime by, so this is the same equation, right? So what we basically conclude from here, so that means I can rewrite instead of these two transformation equations. So if you make go from some unprimed to primed frame, so like x prime y prime to xy, right? So you can generalize it in this form. So that means I can write then x prime I equal to this. So this is our general equation. So this is not only true for this, or you can write for any arbitrary vector. अगर मैं कोई vector लूँगा, right? So if I write for any arbitrary vector, suppose I write here a prime x, instead of these two equations. So I can generalize this as, I can write that a prime I equal to, okay. So I can generalize instead of these two transformation equation, I can write it this way. So this is true for any equation. So instead of this, if you write some velocity or acceleration, so I can generalize it. So instead of these two transformation equations, I can write this quantity in this form, any some vector in this form, right? So this was all about the vector transformation, and we can in our coming lecture, in our next lecture, I'm going to discuss about these vectors as matrices, how we can represent them in terms of matrices, and what are its application. Maybe in our coming lecture we will discuss that. Thank you.